Hello, as promised, we're going to quick go through B. So remember, we now have the mean of this new random variable, which is the scaled scores. So the mean of y was 78.8, and the standard deviation of y is 15.2. So we know that. B says, what is the probability that a randomly selected student has a scaled test score, so we're talking about y, of at least 90? What is the probability that they have a scaled test score, y, of at least 90? Meaning greater than or equal to 90. Now let's think about this. We are not given a probability distribution. We're not given all of the values of the scores, which means this is not a discrete random variable. This is a continuous random variable. And we are told at the beginning that it is approximately normally distributed. So here's what we know. The original x was a normal distribution. We remember that the shape of a distribution does not change when we add, subtract, multiply, and divide. So I know that the distribution of y is also a normal distribution. So I can sketch this distribution approximately normal. I know that it has a mean of 78.8, and I'm not going to add in, oops, that was supposed to be a y. I'm not going to add in my little marks here just because it doesn't necessarily give anything to the problem. 15.2, I'm looking for the probability that she or a student, yeah, it's a she, of course, she's going to score 90 or above. Let's say this is 90, I'm looking for this area right here. Well, how do we do this? We can find a z-score if we want, right? Just to flash back, it's equal to a value minus the mean over the standard deviation, and then we could use table A. But I don't know about you, that's kind of a lot of work, and I don't feel like doing that. So let's go and use our calculators. We're going to go to normal CDF. It will ask us for a lower value. It will ask us for an upper value. It will ask us for the mean and standard deviation. Lower would be 90, because that's where we're starting. Upper is some big number. Plug in whatever big number you want. I usually just put a bunch of 9s. Our mean is that 78.8, and our standard deviation is 15.2. Then we let our calculator do all the heavy lifting. And drum roll, please, if you want to pause the video so you can get it yourself. Otherwise, hopefully you're getting 0.2306, or about 23% chance. And that's what we got for this problem. If you have questions, please let me know. Otherwise, have a great rest of your day.